backslash. So the
Yeah.
options were, I think,
4, 5, and 6, and the answer is 10. That's what you're saying.
The answer is 10, sir.
So why did you run it in the first place?
Sir, what, sir?
So did you run the command?
No, sir. Because obviously, if you give print of a comma b, they'll be printed in two different lines.
Yeah. So
yeah.
Okay, I will cancel the question.
Yes, sir.
Yeah. Okay. Anything else?
Sir?
Yeah.
So I have a question from last lecture. Should I ask her?
Yeah, tell me.
You said range ijk is a bad example for functions with optional arguments, right?
Yeah.
So I didn't fully understand why that's a bad example.
Range ijk, because with one argument, it refers to range j. So with two arguments, it refers to range ij. And somehow the first argument is missing. The only argument is interpreted not as I, but as j.
Oh, okay. Yeah.
So that is the only reason. Correct?
Okay. Yeah.
So the semantics of which one is the first argument, what does it mean, changes.
Yeah.
The meaning of that changes. Yeah, that's right. So, so today we are going to see something called errors and exceptions. So when there's an error in the program, for example, you write 5 divided by 0, then there is an error because there's division by 0, correct? So division by 0. Similarly, there is, if you try to read a file that is not present, or access, or you access Li, where I is a list and I is an index out of range. So you define L is equal to 1, 0, 1, 2, and then you say L3, print L3. Correct? This will raise an error. Correct? It will raise what is called an exception. Correct? So, so such things are called exceptions. And how are they handled? So in C, for example, or in many classical languages, if you have such an error, the program just stops. It just quits. Correct? Now, that is not always the best course of action to take. In Python, what happens is that so before telling you that, let me explain a little bit about the program stack. What happens when you call a function? Suppose you have a function f. You say def f, correct? And inside that you call, and you have a def g, some code, and def f, some code, and you do, let's say, f of, so this is f and fn minus 1, correct? And or gn minus 1, something, correct? And in gn you call fn minus 1, something like that, correct? So now if n is greater than 1, so I'm saying if n is greater than 1, then fn minus 1, something like that. So there's a recursion, for example. This is just an example. So there is something called the function stack, the stack, where you store how function invocations happen. So when you call f10, there is a entry in the stack which corresponds to f10. Now n is greater than 1, so it will call G9. And this will call F8 and so on, correct? So the invocations of functions are like this. And if you, in any call, you have one function calling another that is stacked on top with its arguments. And if that calls another function that's stacked on top of its arguments, when the topmost function finishes, at some point of time, the topmost function in the stack finishes, it returns control to the previous thing on the stack, previous function on the stack, which continues processing. If it finds another function, it again stacks it, and so on. So is the procedure clear?
Yes, sir.
Now, what happens when you have an error or an exception? So in F10, suppose, so Fn, I say if n equal to, this is very artificial code, but if n equal to 5, print n by 0, correct? So what will happen? You would call F10, that would call G9, and that would call F8, and that would call G7, that would call F6, and that would call, so suppose I also have here, so that's an unfortunate choice. I move this to G. And I move. I say if n equal to 5, then print n by 0, correct? So you would call G5, and this would bomb. This would raise an error, correct? Division by 0. So now what happens is this program, this function stops in the middle and goes to F6, back to F6. And then this thing unwinds till this exception is caught. What do I mean by caught? So you can, so is the procedure clear? This exception kind of unravels the execution by which it had arrived till somebody handles that exception. Somebody says that if this exception occurs in the code that I'm executing, then this is what should be done. And what should be done is if that function puts this into a try except loop, try except piece of code, correct? So, correct? So, let me change the code here. Let me say this calls HN, correct? And or let it be. So let me extract this here. And here I write if so here I do in the F's I do try. I do try Gn minus 1 except do something. Let's say pass, which just doesn't do anything. It just is a null instruction, correct? Correct. So with this piece of code, what will happen? G5 bombs. It raises an exception. It will go to F6. Sorry. Yeah, it will go to F6. And in F6, I had called this G5, and this handles the exception. So it would ignore the error and then continue. Correct? So it would execute whatever was here. Is the procedure clear?
No.
No. Okay. So I'm saying try, if you say something like try and write a piece of code, print 5 by 0, correct? And except print got an exception. Correct? So what will happen? When you try this piece of code, print 5 by 0 will raise a raise a division by 0 exception, correct? Which would immediately be caught by this except. I mean, this try would essentially try this procedure, and if an exception is raised, it would do this. Correct?
Okay, sir.
So now I should, let's say, correct? So is this clear? And this, I needn't have written print 5 by 0 here. I could have written a function like h here, hn, correct? And inside hn, if any unhandled exception occurs, then it's caught here. Do you understand what I'm saying? If there is any doubt in anybody's mind, tell me.
Sir,
Tell me.
you said it ignores the error and it continues. Does it like continue in the sense it continues with some calculation, or it just prints got an
No.
exception?
So it says print got an exception and then does whatever is written after this. In the very basic thing, it in hn, if it gets an exception, it abandons hn, comes to this except thing and prints this. And then it continues as if nothing had happened.
No, continues with the definition of f of x and g of x, right?
Yes. So here I have defined f of n. So there's some other function, some a of n. And if I do a of 10, it will come here, try hn, and hn suppose bombs. Suppose I write g of n, correct?
Yeah.
So in a of 5, g5 would bomb.
Yes.
And then this would not go ahead with the execution of g of 5. It would instead come here, print got an exception, and then continue with the further definition of an. Correct?
Yeah, okay.
Sir, if the function that we wrote in try does not give an error, then the except block won't be executed, right?
Then the except block won't be executed.
Okay, sir.
Correct? Except a block is only executed when there is an exception. And you can specify which kind of exception also. Correct? So in gn, suppose you use your function def g does print m. M is not even defined here. Correct? So what will happen? It will raise an exception called name error. So instead of if a name is not defined, then you get a name error. Correct? And you can say here except division by 0. And you can say except name error. And do something else.
Excuse me, sir.
Tell me.
Sir, I didn't get the name error. Can you just explain once more?
So name error means that the name is not defined. The value of the name is not defined. The name has not been initialized.
Okay, sir.
Correct? You're using a name before initializing its value. So similarly, there are lots and lots of exceptions. Like there is index error. there is index error if you access L of I. L is a list, and L of I is not defined. The index, the ith index has not been defined. Correct? L is defined, so there's no name error, but Li is not defined. Correct? Similarly, there is a key error if you access dictionary value I, dictionary value K, and K is an undefined key. For example, you say K is equal to, D is equal to empty, and print D something. Correct? This will raise a key error because something is not a key in the dictionary. Correct? And there is zero division error, and there are a bunch of errors which you can look up. Correct?
So is pass a keyword?
Yes, pass is a keyword. Pass just stands for the empty statement, a statement that does nothing. So it is the placeholder for a statement. It's a null statement. Do you see? So you want to write, here I have written print got an exception. Suppose I don't want to print anything. I just want to fill the space left for this thing. I can't leave this as an empty block. So in that block, I put pass.
Okay, sir.
Correct? So pass.
Sir, sorry.
Tell me.
I know. So if there's a name error, then what exactly happens in the try exception block? Like, could you just repeat that part? Try exception.
In this try except block, name error, whatever you have written here will be executed. You can, for example, say print. So name error also contains. You can look at the syntax, but name error has some key associated with it. That key you can print and so on.
Okay, sir.
Correct? And you can aggregate various exceptions together. You can say except name error, comma index error. And then if either one of them is executed, happens, then you do whatever is written after that. Correct?
Yes, sir.
So basically there are these except clauses, and you can also put a finally clause, which is always executed after everything else in the statement has been executed. Finally is always executed. So you can put a except which matches everything not matched by anything before this, or rather it will, yeah. No, I think the chain. So this will also be executed whenever there is an exception, and finally is always executed. Correct?
Yes, sir.
And you should try it out for yourself to see how these things work. This is just syntax, so the easiest way to learn it is through programming it and seeing how it works. Correct? You can write a simple piece of code which does this, which uses try, except, and so on. Correct? Now, if an exception is not handled, suppose a name error occurs and I don't have this name.
But I don't think you've started recording.
Oh God. Okay. Sorry. So I'll start now.
Recording in progress.
Okay, so I missed some part of this thing. I will post this, whatever I have written, the transcript also in the this time, correct? Is that okay? In any case, that's all I can do. So, so if an exception is not handled, for example, this name error that is not handled here, and a name error occurs above, correct? Then it is passed on to the calling point, where this function, so it is passed on to the next function in the call stack. If it's handled there, it is handled there. Otherwise, it's passed to the next function and so on. Correct? So basically, I'm saying if an exception is not handled in a function, it is passed back to the function, to the calling function. Correct? Correct? So the minimal code that you can write in try except is just try, write the code, and then do except and pass. Correct? This would catch all exceptions and do nothing with them, just continue. So no errors will be caught. Correct? Now you might say that this is a fringe kind of fringe syntax, and you would need it only in exceptional circumstances. Correct? But there are two things that are against this. First thing is you can actually raise exceptions also. Raise value exception. So value exception is something where there's a problem with the value. You say if A is less than 100 or A is greater than 200, then raise value exception. This would only go through without an exception if A lies between less than if A is greater than equal to 100 or less than equal to 200. Correct? Only then we would go through without an exception. So you can artificially enforce exceptions. Correct? Correct? This is to indicate that the value is too small or too large. You only want values between 100 and 200. So this is one use of it. The other, more complicated but very nice use is like in the program we saw earlier. Correct? So what count program did we have? If k in count dot keys, remember this piece of code? We said count k is equal to count k plus 1. Last time we had this piece of code, na? Else count k equal to 1. Correct? So you would have to compute these count keys and look for k in them and so on. Correct? A simpler way is to use exceptions. So you will say if so you would say try this piece of code, you would transform to try count k is equal to count k plus 1 and accept key error what do you do? Count k equal to 1. So you caught the exception when count is not defined, count k is not defined, and then defined it. Do you see my point?
Yes, sir.
Correct. So it's a very natural way of writing things. It's not in the iterative style. You don't have to write a for loop, or you don't have to write an if with k in count.keys. You don't have to extract the keys and so on. You just write try count k is equal to count k plus 1, except key error count k. So you initialize it if there's a key error, if the thing is not defined. Correct. So it's a very elegant piece of elegant technique in writing code in Python with the help of exceptions. Correct. Now let me just go over this. So before, so in what is the time? I still have 25 minutes. Okay, good. So let me do an aside and talk about binary search. Why I am doing this is because you will require it in today's assignment. You are going to get an assignment by today evening, or maximum tomorrow, which will contain a problem, at least one problem related to binary search. So that's a hint, and I'm trying to tell you what binary search is. So is there anybody who doesn't know what binary search is?
So I don't think I know.
Okay, good. So I'll tell you what binary search is. This was like try binary search except whatever. Yeah. So binary search is, suppose you are given a sorted list of numbers. Actually, it works for arrays, but let's suppose you have a list in which you can in constant time index the ith position, correct? The ith element of the list. So a sorted list of numbers, say in ascending order. And by numbers, I mean positive integers, let's say, for definiteness sake. Correct? Now you want to find whether a number is in this list or not. So you are given a sorted list L of positive integers and a target number T. You want to know I such that L of I equal to T, or there does not exist such an I. Is the problem clear?
Yes, sir.
Okay. So how would you solve this problem?
I mean, you go through the list and you check.
That is the best. That's the easiest way to do it. Correct. You sequentially go through the list, and you can do this in any list, whether it's sorted or not. But can you take advantage of the fact that it's sorted to do something better? Can you? So do you have to look at all the elements to find out whether that element is in the list or not?
You
Or
just
can
have to
you
go. Sorry. No, like if it's huge, if the number is huge, then you don't have to look at the first few numbers, like the smaller numbers.
You can do this. Suppose you know the length of the list also, correct? So suppose len of list is also len of L is knowable in order 1 time. And Li, so these are assumptions we make. Assumptions. Li is accessible in order 1 time. Correct? By order 1, so I have not yet defined order 1, but that means constant time. Correct? So in a unit time step, in 1 time step, or in constantly many time steps, you can look at the ith element. I give you I, you give me Li. Correct? In 1 step. Correct? Suppose this fact is clear to you. Then how would you exploit this sorting?
So like you go to a random I, and if it's smaller than L, then you just keep going up.
You could do that. And that might be a very good algorithm to sample some I's randomly in the remaining range. But there's a deterministic way of doing it. So the simplest way of doing it is you look at the middle element. So suppose you look at L of len L by 2, correct? Say floor of this, correct? And check, and you check whether this is equal to T or not, correct? If this is true, then you are done. You have found the element T. Correct? And if it's not true, what do you know? Tell me. That either it is smaller or larger. Correct? So instead of checking this, we check, let's say we check, suppose if, so there are 3 cases. If this is greater than T, L if L len L by 2 is less than T. Correct? There are only 3 cases for this element, correct? And else print found, return whatever, return correct? Now if len L is greater than T by 2, what do you do? So this is not the best way to write it, but let's say our list is from okay, let's see first. So if len L by 2 is greater than T, what do you do? Tell me. So you have this sorted list, L0, L1, and so on till len L by 2, the middle element till L of len L minus 1. Correct? Now what do you know? That your T is smaller than this. So T is, if it exists, must be here in this case. And in this case, it must be here. Correct?
Yes, sir.
So you have essentially halved the length of the list in which this element can lie. Correct? So now, and I'm just writing pseudocode, you search L1 0 colon len L by 2 minus 1. Correct? Here you search len L by 2 plus 1 colon, correct? So I could just write this as slices. Now you might say that slices destroy the whole purpose because we are copying lists. So we'll come to that in a minute. But if you could do this in one shot, then this would be done, correct? By this. So more formally, I would say bin search L. One version of bin search L would be return this. So, and I have to supply base cases, which is if, so small cases you have to handle explicitly. When length of L is less than equal to 2, what do you do, correct? Or less than equal to 1, what do you do? If len L equal to 1, then return L0 equal to T, correct? LF, yeah, correct? Are you with me?
Yes, sir.
So now this is inefficient. Why is it inefficient? Because you are copying this list, you are making a slice of this list, and that would take presumably time proportional to the length of the list, correct? At least proportional to the length of the list. So instead, what you would like to do is to do it in not make copies, correct? So you would define this in this way. You would define def bin search modified. You have a list L which you pass, and something called low and something called high, correct? So you are only searching for this between low ... high, correct? And now you can write the code more precisely. If low equal to high, then return L low equal to T. So there is also an argument T, correct? Equal to T. Elif. Now you do the other thing, correct? I mean, you say L of low plus high percent div 2 is greater than T, then binary search modif L comma low plus so if we also have to consider a case when low is greater than high, return false, return -1 or something, correct? Or return false, let's say. So, but false would be 0, so return -1. And here we would say return, so I would have to modify this. So I would write if low, L of low is equal to T, return low, else return -1, correct? And then you do binary search low plus high, L comma low plus high by 2 -1, correct? Comma sorry, what am I writing? So I have to do L comma low plus high by 2 minus 1 comma T. So high I have shifted to low plus high by 2 minus 1. Else bin search modif else if L of low plus high by 2 is less than T, then modif L comma low plus high by 2 plus 1 comma high comma T return, and there should be elif. Correct? Else return low plus high. Correct? Are you with me? So tell me.
Yes, sir.
So does anybody have objection with this? So this would either return the index such that index I such that L of I is equal to T, or it would return minus 1. Otherwise, it would return minus 1. Correct? Is this clear?
Sir, I had a question. In Python, are there ways to define functions locally within other functions? And if so, is this recommended or not recommended?
You can define local functions, of course, anywhere. So in any, the scope of the local function will be restricted to the, I think it is restricted to the function inside which it is defined.
Okay. And
we will see more of such things when we define classes. And there are anonymous functions also. And all that we will see later. Correct?
okay. Okay, got it, sir. Thank you.
Yeah.
Sir, it's L of L0 plus hi by 2, right?
Sorry?
Sir, it's L of L0 plus hi by 2. The last line.
No. We want to return the index.
Okay, sir. Yeah.
Correct? So, so that's one thing. Now, I told you, so coming back to the lecture, I told you about this, what do you call it? Print and input and so on, correct? So print can take variable number of arguments. This is the first argument. This is the second. And this is the third. Correct? So this is the first argument, this is the second argument, this is the third argument. You can add as many arguments as you want. You can put in, this is the first one, second two, something, some numbers in between, this is the third three, correct? Things like that, correct? And so variable number of arguments are permitted in print. Like in the quiz, with the unfortunate question in the quiz, you can print \n for new line, for starting a new line, and print something, prints something on a line and then goes to the next line. Correct? So if you print, you have two print commands, they would print like something and else. Correct? And if you add an extra new line, then there would be a gap in between. There would be a line in between. There'll be 4 lines. So that is what I had missed in today's quiz, and I will remove. I mean, the point was to see that this range goes from 0 to, when you say 0 to 5, there are 5 lines printed. The new line is just a distraction. Correct? So this is for tabs, and similarly you can add other these things, characters, escape characters. These are called escape characters, and you can and yeah. So the next topic I am going to deal with next time, not this time, is file IO. Correct? So let's start that next time. And thus far we have done, today we have done just errors and exceptions and a bit of binary search. Correct? So thanks and have a nice day.
Thank you, sir.
Thank you, sir.
If you have questions, no questions, huh? Okay, thanks. Bye.
Thank you, sir.